example 5, and it says solve 5 to the x plus 2 equals 4 to the x. And the first thing I want you to notice is what? The bases are different. The bases are different. So that's the first thing. We learned the rule that says if my bases are same, then the powers are the same. And I set my powers equal to each other and solve for x. Easy peasy. Here, the bases are different. One base is 5, one base is 4. So your notice is not the same. Your wonder should be, what do I do now? Okay? Did y'all do notice and wonders when y'all were in junior high? Yeah. Ugh, notice and wonder. Anyways, this is that. We notice they're not the same. Your wondering is, what do we do? So in order to kind of access the exponents, okay, you see that the exponents have the x's in there? That's our problem. So I can't invert it like if it was x squared, I would square root to get rid of the x squared, right? If it was 2x, I would divide by 2 to get rid of whatever was with x. The problem here is that x is up in the power spot. The inverse of an exponential is what? No. We're drawing a blank. So we learned just recently, we learned two kinds of functions. We learned exponential functions, and then we learned the inverse function of that, logarithmic. Okay? So the inverse of an exponential is a logarithm. So these are exponential problems, both sides, exponential. To undo the fact that they're exponential, we do what we call log it. We're going to log both sides. Okay? You can log both sides in any base, as long as the base that you choose for both sides is the same. It's very typical that unless one of these bases is 10, which they're not, one's 5 and one's 4, unless one of the bases is 10, we choose the natural log. It's fewer keystrokes, it's automatic base E, and it's pretty simple to solve these with a natural log. Okay? So here's how that works. We're going to natural log both sides of the equation. We're going to have natural log of 5 to the x plus 2 equals natural log of 4 to the x. So far, so good? Yeah? Now, this still didn't solve my problem of getting those exponents down. I need them on the base level with everything else so that I can solve. But if you'll remember the power property of logarithms, what does the power property say? Yes, if something is raised to a power in the argument, you can pull it down as a coefficient. Are y'all remembering that rule? So these could be actually rewritten as x plus 2 times the natural log of 5. And we would set that equal to x times the natural log of 4. Pull that x down. Is that feeling better? Okay. Our next couple of steps are a little bit less straightforward. The first thing you want to do is, this is a monomial. This is a number, natural log 5. It's like the number 7. It's not 7, but it's just a number. We're going to distribute that number through this binomial, x plus 2. So this is going to come out as x natural log 5 plus 2 natural log 5. Did y'all see what we did there? We distributed the natural log through the binomial, equal to x natural log 4. Remember, we're solving for x. We're trying to isolate the variable x. So in our next step, what we're going to do is we're going to move everything that has x to the left side. We're going to subtract it from the left side. And everything that doesn't have x, we're going to send to the right. So we're going to subtract that 2 natural log 5 from the right side. Can you see what we did there? So we moved the x piece to the left and the not x piece to the right. which brings me to a statement that says x natural log 5 minus x natural log 4 equals negative 2 natural log 5. Are y'all with me? X natural log 5 minus x natural log 4 equals negative 2 natural log 5. So we just flip-flopped the two pieces that were in the wrong space. But when we change them, we change their signs as well. Now, why did we do that? This is a pretty common step to make. We do this a lot in pre-cal when we're solving inverse functions. We do this a lot in calculus when we're doing something called implicit differentiation. A lot of times you'll need to get every piece that has that variable that you're looking for in it on one side of the equation and everything that doesn't on the other side, so that you can factor out the variable. Can you tell that both of these terms have x in there right now? If you factor that x out, you can then divide by what's left and we'll solve for x. So we pulled that x to the front, factored it out. The only way we're able to do that, though, is if we have everything with x on one side and everything that doesn't have x on the other side. Now we have one step left. We're going to divide by everything that's over here. In my last class, they preferred to call this x times natural log of 5/4 because it's natural log 5 minus natural log 4. And the quotient rule says if they're subtracted, I can consolidate by dividing. I liked that move. I thought that was a nice idea. So now we can divide by that natural log 5/4. And so our final answer here is x equals. On top, we have natural log. If I send the negative 2 to the 5 as a power, what's 5 to the negative 2 power? 1/25. So 1 over 25. If it was 5 squared, it'd be 25. But it's 5 to the negative 2. On bottom, we have natural log of 5 over 4. This is your final answer for example 1. This is a whole lot. And it's super yuck. I'm not a big fan of this problem. I gave you one of these in your homework. I'm willing to work it with you right now if you'd like that. Okay. The rest of this lesson is fast. And the rest of your homework is fast. But this example and the one problem from the homework are yuck. Okay? Like the whole day, that we were going to spend the whole day on that one concept? Yeah. No. Let's do one problem and we'll be done with it. Yes. I don't know what your question was. I just said yes. Okay, so here's number 20. It says 2 to the x plus 1 is equal to 5 to the 2x minus 1. And again here, I have different bases, and I have my x's in powers. And the only way to get up there in the power is to log it. Okay? When I log both sides, I want to use the natural log because neither one of the bases is 10, and natural log's fast and easy. So we're going to use the natural log. When we natural log the 2 to the x plus 1, what's going to happen to the x plus 1? It's going to come to the front. So can we agree that this is going to become x plus 1 times natural log 2? And we don't have to show all of those steps. Equals... equals 2x minus 1 times natural log 5. Are we all in the same place here? Now, we want to distribute our constant, which is natural log 2 on the left and natural log 5 on the right. So we're going to push this natural log through x and through 1. So it's going to become x natural log 2 plus, you could write 1 natural log 2, or we could just write natural log 2. Good? Equals, we're going to push the natural log 5 through. 2x natural log 5 minus natural log 5. Okay? Now what do we want to do? Move all the x stuff to the left, move everything without x to the right. And really, you're okay to just change signs as long as you do change signs. Okay, so I want it to say x natural log 2 minus 2x natural log 5 equal to negative natural log 5 minus natural log 2. Now what? Why did we put everything with x in it on one side? So we can divide it out. So we can factor that x out. Do you see that x is in both terms? So you can steal it back. It's like a cupcake that has been distributed already, and now you're going to take it back. You're ungifting the cupcake. So we have natural log 2 left minus 2 natural log 5 equal to negative natural log 5 minus natural log 2. Everybody okay? Still breathing? What's our last step to get x by itself? Say it louder. Divide. Divide by all this stuff that's not x. Divide by natural log 2 minus 2 natural log 5. Divide by that on both sides. And there's not really any simplification that I need from you. I'm good with this being your answer. You can't cancel anything because there's nothing being multiplied. We don't get to cancel when we're just adding or subtracting. So that's it in all its ugly glory. Huh.
If one of the numbers in the equation is negative, can I put a logarithm? Yes.
I think so. All right, let's move on. Let's do better problems now. Does that sound good? Yeah? Get out of the nasty. These next problems are going to be equations. Equations containing the number e. Equations containing e. What's e? 2.71, yeah, something like that. Okay, what's pi? See, you should know e. Y'all should say e with the same volume that you say pi.
What was it again?
Huh?
What was it again?
2.7187. Okay, here we go. This is example 6, and it says 100 equals 20 times e to the 2t power. And we're trying to solve. Bryson, you got any ideas?
Nope.
Really? No first move here? No gut instinct? See, you're right. Divide by 20. Divide both sides by 20. We want to isolate the e to the power. What's 100 divided by 20? 5. So 5 equals e to the 2t. Now, I don't have the same bases, right? And I'm trying to get in the exponent. What do I want to use? Do I want to use a regular logarithm or do I want to use a natural logarithm? Why, Gracie? Because this exponential has e. That's exactly why. Okay, so if we natural log both sides, watch what happens. Natural log of 5 equals 2t natural log e. I went ahead and swung that power down. Y'all following what I'm saying there? But what is the natural log of e? What is this piece right here? Leo says that's equal to 1. Why? Anybody can tell me why natural log of e is 1? Because the base is e. Okay, so I want to revisit this thought. If I have log base e, which is natural log, I'm just trying to show you something. Log base e of e equals question mark. What am I asking here? I'm saying e to what power gives me e? 1. So the log base e of e is 1. In other words, natural log of e is 1. So that part of your equation gets handled. It goes away. And all you're left with is natural log of 5 equals 2t. So solve for t. Divide by 2. T is equal to the natural log of 5 divided by 2. Another way to write that is to call it half the natural log of 5. Right? If I divide something by 2, it's the same thing as multiplying it by 5. Give me one more version of this same information. The natural log of, say it louder, square root of 5. How'd she get there? Yeah, so she moved the coefficient half to the power position on the 5. And we ended up with a square root. What'd you think of this one? Wonderful? She said wonderful. Is wonderful a stretch? Yeah. Okay. All right, let's do it. Try it. Let's do a try it. This one says 3e to the half t equals 11. Anybody have an idea?
That's 1/2.
It's 1/2 t. Uh-huh. Okay. Divide by 3. Divide by the 3. Skim it down to e to the power first. Okay, how do I get to the power? I want to bring the power down. So if I natural log both sides. Now, what's the natural log of e? 1. So really, all that's going to be left on the left is half t. So I have half t equals 11/3. Why not, Leo? I didn't natural log the other side. That's what I'm trying to get you to realize. If you natural log the left side and you say, all I have here is half t, you're correct. But if you forget to natural log the other side, you're in trouble. What you do to one side, you have to do to the other. So if you natural log the e side to get rid of e, you've got to natural log the other side. Are y'all following that? So I have half t. How do I get rid of the half? You could divide by half, which is the same as multiplying by 2. Multiplying by 2. So t actually equals 2 natural log of 11/3 or natural log of 11/3 squared. That could be it. Anybody have any questions here? Make sure you natural log both sides. Okay, that's going to be your issue that you have on that kind of problem. All right, let's do example 7. We're cooking with gas today. Y'all doing okay? I assume no response means yes. We're doing fine. Thank you. Yeah? Okay. 4e to the 2x plus 5 equals 12. 4e to the 2x plus 5 equals 12. What do we want to do first? Nope. PIMDAS. Add, subtract first. Add, subtract first. Lose the 5. So we have 4e to the 2x equals 7. Now divide by the 4. So e to the 2x equals 7/4. Now what? Natural log both. So what do we end up with on the left? 2x equals natural log of 7/4. And then divide by 2. X equals the natural log of 7/4 all divided by 2. Or half the natural log of 7/4 or natural log of the square root of 7/4. All of these are options. We thinking pretty good here? Okay. Are we getting dive bombed by a fly? Is that what's happening? Okay. Can we handle it? Can somebody kill it? I don't know. All right, here's example 9. 2 natural log of x plus 3 equals 7. Now we're going to go the other way. 2 natural log of x plus 3 equals 7. Move the 3. Bless you. 2 natural log of x is 4. Golly, that was it. Real country, 4. Divide by 2, she said. We agree? Divide by 2. Divide by 2. Natural log of x equals 2. How do I solve for x? E. Okay, so remember this. Log base b of c equals a. If I were to write that in exponential form, I would have b to the a equals c. Can you tell that in this particular problem, I'm looking for the argument c? So I can solve for x by taking the base to the power. What's the base? E, because it's a natural log. The base is e. So e to the second power is x. E to the second power is x. Any questions on that? Okay. Let's do a try it. We have 2 natural log of x plus 1 equals 10. What are you thinking, Jessica? You got moves? Yes, you do. Look at it. 2 times natural log of x plus 1 equals 10. Divide by 2, she says. She did say. I read her mind. Natural log of x plus 1 equals... Now I subtract 1? No. You do not get into those parentheses until after you've handled the natural log. Okay, we go PEMDAS, backwards. Parentheses are last. So we've got to undo the natural log first. How do we get rid of that? E. We write it in exponential form. If I were going to convert this equation into exponential form, I would take e to what? E to the fifth. So e to the fifth equals x plus 1. Now you can subtract the 1. So your x is equal to e to the fifth minus 1. Are we mind blown?
Yeah.
We're okay? No? Yeah? Okay. Wait. Okay. She said, wait. Hold the phone. Okay. Ready to go on? Okay. This is the last one. This is going to be example 12. We've got a it and a try it. Okay. This is the thought process that we have here. If I have log base b of s, that is equal to log base b of t if and only if what? S equals t. So this is very similar to the rule we were using for exponential equations. Very similar. If my bases are equal in a logarithm, then the arguments are equal. Kind of feel where this is going? Maybe. Here's example 12. It says natural log of x squared equals the natural log of 2x plus 3. The bases are equal. What's the base, Maddie? E. So if the bases are equal, the arguments are equal. So she said set the arguments equal to one another. X squared equals 2x plus 3. Long ago, in the olden days, when they were presented with a quadratic equation, how did they solve it? Set it equal to 0. By hand, yes, they did. They set it equal to 0, and then what? Starts with an F. Factored. Okay? They didn't go in here and do any of this business where we want to just start square root and miss. No, they did not. That is not how we solve a quadratic equation. Okay? Resist the urge to do some weird algebra. Do what you know. It's quadratic. I'm going to set it equal to 0, which means I'm going to subtract the 2x. Going to subtract the 3. So I'm going to have x squared minus 2x minus 3 equals 0. We factored for an entire semester. But all of a sudden we get to this place and we're like, I didn't know what to do. Never seen that before. Jaden, you got factors in -3 that make -2? -3 and 1. X minus 3. X plus 1 equals 0. So x equals 3 and x equals -1. Perfect. We should check them and make sure that both of these work. Remember that there's always a possibility that my solutions are extraneous. So we want to make sure that they work in the logarithm. So how would they not work in the logarithm? What can I not do with a log? I can't log a negative number. So if when I plug these back in, here and here, I need to get a positive. Try 3. Do I get a positive argument in both places? Yes, I get 9 or I think 9, right? Plug in -1. What's -1 squared? 1. It's positive. What's 2 times -1? -2. But I add 3. Now it's positive. So both of my answer choices are able to work here. I cannot log a negative number. Heads up on your homework. You cannot log a negative number. Okay. I think that's good for today. You want to be done? Sweet. No solution. Can't log a negative. Everybody good here? Okay. So your homework is due on this 6.2 homework. Let's try to grade it by the end of class tomorrow. If not, by the very beginning of class on Friday. You have 2 days to get ready for your test. What day is your test? Monday. You get to use your notes. Your test will cover 6.1 through 6.6. Okay? There will not be a review. I'm not telling you what designated problems to be studying because you get to use your notes. You understand? Big test. It's going to cover lots of material. Everybody okay? Monday. All right.
Using problems at least from our homework.
Yeah, absolutely. Absolutely. No test questions that haven't already been assigned to you in your homework. All of your tests will come from your homework.
There'll be one of those on the test. Okay.
So just homework questions?
Homework questions on your test. Just like always. I'm only pulling questions that you've already worked from your homework. You're going to get to use your notes. You will not get to have like a concise review.